Well, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant, and we are looking at question 24 from the 2022 Pascal contest. In this question, we are looking for pretty numbers. And pretty numbers are just these numbers that have these properties. The first three digits are a perfect square. So ABC is a square. The rightmost four digits, is a cube. Okay. And the tens digit, the 10,000s digit and the units digit are the same. Very interesting. So both the square and the cube have to end in the same number, and the thousands digit is not 0. We're not interested in cubes smaller than 1,000. So that's what we're looking for. Now, if I told you that I already did some beautiful work and I answered this question up here, but my mistake was I put the cube there and the square there, and I did all this work, and it's very similar to the work we're about to do together, but it's not the same. There's not the same number of pretty numbers. So sometimes we make mistakes, and that's okay. The main thing there is read the question carefully. I was fooled by the words leftmost and rightmost. Okay, so let's go. Okay, so where to start our search for something like this? Definitely, starting with the cubes is a good idea. The reason is there aren't all that many cubes that are exactly 4 digits. Like there's a lot of squares that are 3 digits, but not that many cubes that are 4 digits. So that's a better list to look at. Let's build the list together, shall we? So we have 10 cubed is 1,000. That's pretty easy. But I don't happen to have a lot of cubes memorized. I happen to have 11 cubed memorized. This is 1, 3, 3, 1. But past that, we're going to use a calculator. So go ahead and build your own list. And you just do it this way, right? Like 12, do it to the power 3 is 1728. Okay, so you build your list and see when you go over 10,000, because then you're 5 digits. And I'll do the same, then we'll meet back here in just a second, okay? So here's my list. Okay, and I know I can stop at 21 because 22 cubed is going to exceed 10,000, and I can just tell by the gap between 21 cubed and 22 cubed. I don't happen to have 22 cubed memorized, but there it is, bigger than 10,000. Okay, so there we go. This is a very useful starting point. There's only 12 cubes that we have to consider. Next, we also know next thing that we're going to look for is any other way to limit our thinking, because if we have to, the more options we have to consider, the longer these problems take. And so this here, it's 10,000s digit and its units digit are equal. Like the last digit in this cube has to be the last digit in the square. And there's a very cool property about the squares and their final digit. The final digit of a square, I'll do this, any work I do about the squares I'll do in blue. The final digit of a square cannot be 2, 3, 4 it can, 5 it can, 6 it can, 7 it can't, and 8 it can't. These 4 digits, we can never have a square that ends in those digits. It's very cool. No, there's no squares that end in those digits. It's possible to prove this, and it is something that comes up in the Math Mastery Academy. Like this is a skill that we look at in one of our classes. All right, so what that allows us to do is we can go in and we can say, this one, we don't need to consider that. We don't need to consider that. We need to consider those ones. We need to consider that one. But we don't need to consider this. We don't need to consider this. And the rest we need to consider. Okay, so the rest are candidates. But that just cut out a bunch of stuff that we don't need to look at. Okay, so now let's do the cases. And now the last place that we're going to really, it's going to narrow things down but more sort them into cases now, is to make sure we get everything, is just like saying, let C be this, let C be that. So here's how I'm going to do that, and I'll do this in black. Case 1, c equals 0. So I'm just going to consider 0, 1, 2, 3, 4, 5, 6, all those numbers that the square can end in. Okay? So if c is 0, then we have two ways that we can do that. Okay? I can be using 1,000 or 8,000, right, as my cube. And then, so there's two options there. And then what squares end in 0? Okay, well, let's look at those. We have, and then here, these are not hard to count, actually. There's 10 squared is 100. The next square that ends in a 0 is 20 squared is 200. It has to do with the properties of the last digit, creates the last digit of the square. And then 30 squared is 900. And I was thinking about something else when I said that 20 squared is 200. Of course it's 400. Okay, so those are our three options there. That actually gives us 6 pretty numbers. Okay, so I'm going to write those down here. We've got 6 in this case. I write things down like that I want to count, like I make sure that I remember them. I've got 3 options there and 3 options there, so it's 2 times 3. Okay. Now let's look at case 2. C equals 1. All right. So we've done case 1, c equals 0, and we got 6. Case 2, we are going to look for when c is equal to 1. And there are 2 options, okay? 1, 1, 3, 1. 1, 1, 3, 1. Or sorry, 1, 3, 3, 1. And 9, 2, 6, 1. Okay, so what squares will end in a 1? Well, 11 squared will do it. And notice that it's like 1 times 1 on the end is 1. But there's another way, and that's 9 times 9. So we have 11 squared is 121. 19 squared is the next square that ends in a 1, so that's going to be 361. And then the next square that we have to consider is 21 squared. That's 441. And then 29 squared is, let me do my arithmetic, 841, I believe. Let me see. Yeah, let's say 41. And then beyond that, and then we've got 31 squared as well. 31 squared will also do it, and that's 961. Okay, so there's our, and then the next one bigger that ends, the next square that ends in a 1 is 39 squared, and it's past that. And how did I know that it's only those squares? Well, again, I'm just thinking about that last digit, and you need a last digit 1 or a last digit 9 for your square to have a 1 at the end. And you can just know that by looking at the single digit integers and their squares. Okay? So we have how many options here? We have 10. There are 10 pretty numbers here because we have 2 options there and 5 options there, so that's 2 times 5 is 10. 10 pretty numbers we need to consider. Case 3, c equals, can't be 2, can't be 3, but it can be 4. Okay, so let's see, what do we have there that ends in a 4? Only one number, and that's 2744. So let's take that, 2744. That's 14 cubed. Okay, and now let's count up all of the different ways you can have a square that's 3 digits and can end in a 4. So there would be 12 squared. So 2 times 2 is 4. So 12 times 12 is 144. Okay, so it ends in the right digit. Then what other squares end in a 4? Let's see, 6 squared? No. 4 squared? No. 8 squared? 8 squared. 8 squared ends in a 4 because 64 ends in a 4. So I'm pretty darn sure 18 squared is going to be one of those, and it's just, sorry, I like doing my arithmetic myself. It's 324, I believe, and you had a calculator for this, so if you're wanting to speed things up, you can just do that, 324. Okay, and the next one will be 22 squared. That's 484. And then 28 squared is 400, 720, 784, I believe. Yeah, I'm 99% sure. 784, yeah, good. And then we don't need to consider 32 squared because I happen to know that that is bust. It is too big. Watch. It's too big. 32 squared. See? It's a power of 2, and it is 1024. So those are all of them. So there are only 4 pretty numbers there because we only have 1 cube to use, and we have 4 squares. Okay? And let's go case 4. C equals 5. Well, that's fine. There's 1 cube that ends in a 5, and that's 3375. So let's write that down. 3375. And how many squares end in that? Well, I happen to know that your units digit has to be a 5 if you want to be a square that ends in a 5. So we have 15 squared is 225. 25 squared is 625, and that's it. So there are 2 numbers here. 2 pretty numbers. Okay. Case 5, we're going to have C equals 6. Am I going to fit all this here? Yeah, I only have one more case, right? 7, 8, 9. Yeah, I only have one more case, so I'm good. Okay, so if C equals 6, there is only 1 cube, and that's 16 cubed, 4096. So let's write that down. 4096 in orange instead of red for some reason. I actually like the orange better. And now let's see what squares end in that. Well, let's see. 4s. If your units digit is a 4 or a 6, then your square has a 4 or a 6. Sorry, ends in a 6. So we have to consider 14 squared, 16 squared, 24 squared, and 26 squared. Not 34 squared because that's too big, and I can calculate these for you because, I mean, why wouldn't you calculate these if you were just like here doing this? This is 256. I have that memorized, but the others I don't actually. Oh, yeah, this is 196. I do have that memorized. 24 square, geez, 576. Okay, I'll check that one in a second. And then this one, 26 squared. I hope this is fun, watching me squirm. 640. 676, I believe. 26 squared. I don't even need it for this problem. Like, I just need to count the thing, and I know it ends in a 6. So why am I doing this? I like to learn, and I like to test myself. So there's 4 such numbers there. Okay, so we want to make sure we count those 4, and that's good. And now we're on to case 6. Where C equals 9. There's only one way to have there's 2 ways, sorry, to have your squares end in 9, and that's your units digit has to be a 3 or a 7. Okay, so how many ways are there that have a cube that ends in 9? Well, there's only one. There's 6859. 6859 is our cube. At this point, it would be good to check and make sure we've used all the cubes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. Okay, there were only 8 cubes we had to consider, and we have now used all of them. And we also know that 13 squared, 17 squared, 23 squared, and 27 squared are the squares that will do this. Your units digit has to be a 3 or 7. So there's 169, just for being thorough. 70 squared is 289. 23 squared. 529? Yeah. And 27 squared is 729. Okay, So there's 4 of those. And now we just count them up. So we have case 1, there were 6, 10, 20, 22, 26, 30. Did I spell pretty right? Yes, I did. There are 30 pretty numbers. There you go. So that's how I would approach this problem. Any questions, hit us up in the community. Otherwise, thanks so much for showing up for your math learning. Bye for now, everybody.